Right now, somewhere above your head, engineers are testing something that sounds like it belongs in a movie. A ship that doesn't burn fuel to move. A habitat that grows its own food on Mars. A rocket that lands itself upright again and again, like it's nothing at all. And here's the part that gets me every time. None of this is fiction anymore. You've probably seen the headlines flash by. Elon Musk, NASA, China's new station in orbit. Maybe you scrolled past them the way most people do, thinking, that's cool, but it's far away. Decades away, not something I'll actually see. What if I told you that's not true? What if the future of space travel isn't something your grandchildren will read about in a textbook? What if it's something you're going to watch happen with your own eyes? Maybe sooner than you think. Stay with me, because by the end of this video, the sky above you is never going to look the same again. Let's go back for a second. Not centuries back, just a few decades. In the 60s, going to space meant burning through a rocket the size of a skyscraper, using it once, and watching it fall into the ocean like garbage. That was the price of leaving Earth. You built something extraordinary. You used it for 11 minutes, and then you threw it away. For 50 years, that's just how it worked. Nobody questioned it. It was the cost of doing business with gravity, and then, one day, a rocket came back down. Not crashed, not burned up. It came back down on its own legs, slow and controlled, like it was stepping off a ladder instead of falling out of the sky. The people watching that first landing didn't cheer like you'd expect at a launch. They went quiet, because what they were looking at didn't match anything they understood about how this was supposed to work. That's the moment I want you to sit with, because that single landing changed the math of everything that came after it. Here's what I mean. When you can reuse a rocket instead of throwing it away, the cost of reaching space doesn't drop a little. It drops by a factor of 10, sometimes more. And when something gets 10 times cheaper, it doesn't just become more affordable. It becomes a different kind of thing entirely. Think about what happened to air travel once it stopped being reserved for the wealthy. Think about what happened to computers once they stopped filling entire rooms. The technology didn't just improve. The whole relationship between people and that technology changed. That's what's happening to space right now. Quietly. While most of us are looking somewhere else. There are more objects in orbit around this planet today than at any point in human history. Not because governments decided to compete again, because private companies figured out how to make it cheap enough to be worth doing. Satellites bringing internet to places that never had it. Cargo ships resupplying a station that's had humans living on it continuously for over 2 decades now. Test flights of vehicles designed to carry people, not just equipment, to another world. And I know what some of you are thinking. This still feels like something happening far away from you. Something for astronauts, for billionaires, for people in white coats at mission control. I used to think that too. But here's the thing that changed my mind. Every major shift in how humans move through the world followed the exact same pattern. It starts as something only a handful of specialists can access. It looks impossible, or pointless, or reserved for people very different from you. And then, quietly, the door opens a little wider than anyone expected. Ships that crossed oceans used to carry kings and cargo. Now they carry tourists taking selfies. Planes that once required a military budget to operate now get you a seat for the price of a nice dinner. I'm not telling you that you'll be booking a ticket to Mars next year. That's not the point, and I don't want to sell you something that isn't true. What I'm telling you is that the distance between here and there is shrinking faster than most people realize. And the people building it aren't waiting for permission from the future. They're building the future right now, with the tools we already have. There's a reason this moment feels different from every other time we've talked about space travel. Every other time it was a promise, a concept drawing, a press conference with a model on a table. This time it's hardware. It's engines being test-fired in the desert. It's landing pads getting used over and over until reusability isn't a headline anymore. It's just Tuesday. And that shift from promise to routine is the quietest revolution I can think of. Because revolutions that make noise get remembered. Revolutions that happen quietly get missed until they're already finished. I think that's where we are right now. Somewhere in the middle of a story that's going to look, in hindsight, like the most obvious thing in the world. Like, of course this is how it happened. Of course rockets became reusable. Of course humans went back to building outposts on other worlds. How could it have gone any other way? But right now, in this moment, it doesn't feel obvious. It feels like something you have to pay attention to catch. So let's pay attention. Because what's coming next isn't just about how we get off this planet. It's about what we find and what we build once we're not standing on it anymore. There's a place on the moon that scientists have started calling water in the dark. Not because it's poetic, because it's literal. At the poles of the moon, there are craters so deep that sunlight has never touched the bottom of them. Not once, in billions of years. And in that permanent darkness, in temperatures colder than anything you felt in your life, there's ice, frozen water, sitting there, waiting. I want you to think about what that actually means for a second. Water means you don't have to carry every drop of what you need from Earth. Water means oxygen to breathe if you know how to split it apart. Water means fuel if you know how to turn it into hydrogen. A crater full of ice on a dead, airless rock 238,000 miles away might be the single most valuable resource in this entire story. That's why the moon isn't the finish line anymore. It's the gas station. For most of my life, and probably most of yours, the moon was something we already did. A flag, some footprints, a story your grandfather told you about watching it on television. Finished business, old news, the kind of thing you learn about in a history class, not a science class. But that's changing. Right now, there are missions being planned and some already flown to go back. Not to leave another flag. To stay. To build something that looks less like an expedition and more like a settlement. Solar panels bolted into lunar soil. Habitats buried under a layer of regolith thick enough to block radiation. Rovers mapping out exactly where that ice sits, so the first permanent base gets built in the right spot the first time, because getting it wrong costs more than money. It costs years. And here's where it gets strange, in the best possible way. The moon was never really the goal. It's practice. Practice for keeping people alive somewhere that wants to kill them in about a dozen different ways. Practice for growing food without soil. Practice for recycling every drop of water a human body produces, because out there, nothing gets wasted, nothing gets thrown away. Practice ultimately for Mars. I think about that a lot. How the first real step towards another planet isn't a rocket. It's learning to survive in a place 3 days away, so that when we go somewhere 6 months away, we already know what we're doing. There's something almost tender about that, if you let yourself see it. Before you run, you crawl. Before you leave the neighborhood, you learn to walk to the end of the street and back. Humanity is doing that right now, at the scale of a species, with the moon as the end of the street, and Mars waits at the other end of that walk. Everything about Mars is a study in contrast with home. The sky isn't blue there. It's a dusty, rust-colored pink because of iron in the soil, the same iron that gives the planet its color and its name. A day on Mars is close enough to a day on Earth that your body wouldn't notice much difference. 37 minutes longer, that's it. But a year there is almost twice as long as a year here, because Mars takes longer to circle the sun. The gravity is roughly a third of what you're used to, which means the muscles you use just standing up, just existing, wouldn't need to work nearly as hard. Scientists still don't fully know what that does to a human body over years, not months. That's part of what these smaller missions, closer to home, are trying to answer first. None of this is easy. None of this is guaranteed. I'm not going to sit here and tell you that in 10 years we'll all be watching live streams from a colony on Mars, because I don't know that, and neither does anyone else, no matter how confident they sound in interviews. What I do know is this: the distance between imagining it and doing it has never been smaller than it is right now. in your lifetime while you're watching this video. And that changes something in how we should be looking at all of this. Not as science fiction happening somewhere far away from us, as a slow, deliberate, very human process of learning to leave home. The same way every generation before us learned to cross an ocean, or a continent, or eventually the sky itself. We're just doing it one crater full of frozen water at a time. Here's something nobody puts in the trailer. Getting to Mars takes about 7 months. Not 7 hours in a cramped seat with bad food and a movie playing. 7 months, sealed inside a metal box smaller than a 2-bedroom apartment, with the same 3 or 4 people, floating through a void that doesn't care whether you live or die. No fresh air, ever. No open window. No walk outside to clear your head. Just recycled oxygen, recycled water, and the sound of a life support system humming in the background 24 hours a day. Because if that sound ever stops, so do you. I think that's the part of this story people skip over. We talk about the rockets, the landings, the shiny hardware. We don't talk enough about what it actually costs a human being to sit inside that hardware for months at a time. Let's start with the body, because the body doesn't lie about how hard this is. Without gravity pulling down on you constantly, your bones start losing density. Real, measurable bone loss, similar in some ways to what elderly people experience, except it's happening to astronauts in their 30s and 40s. Your muscles weaken because they're not fighting anything anymore. Your heart, which spent your entire life pumping blood upward against gravity, suddenly doesn't have to work as hard, and it starts to change shape because of it. Fluid shifts upward too, toward your head, which is part of why astronauts come back looking slightly different. Puffier faces, thinner legs. Some of them describe it as feeling like a stranger in their own body by the time they land. And that's just from months on a space station, orbiting relatively close to Earth, still protected by our planet's magnetic field. Out past that shield, on the way to Mars, there's another problem: radiation. Not the kind you get from a dental X-ray. Cosmic radiation. Particles from exploding stars light years away, moving fast enough to pass straight through the walls of a spacecraft and straight through a human cell. Scientists still don't have a complete answer for what months of that exposure does to a person over the long run. That uncertainty alone is one of the biggest walls standing between us and Mars. But I don't think the hardest part is physical. Imagine being sealed in a small space with the same handful of people for the better part of a year. No days off, no going for a drive to be alone for an hour, no calling someone back home and hearing them answer right away because even a message moves slower out there. The farther you get from Earth, the longer it takes for your voice to reach the people who love you. Near Mars, that delay stretches out to over 20 minutes each way. A conversation stops being a conversation. It becomes something closer to writing letters and waiting. Think about the last time you felt truly homesick. Now imagine that feeling with no fix available, no flight home, no hug waiting for you at the end of a bad day. Just distance and time and the quiet discipline of getting up and doing your job anyway. That's the part of this story that moves me the most, honestly. Not the engineering. The people willing to sign up for that, to trade comfort and closeness, and the simple ability to walk outside and feel wind on their skin for the sake of pushing the edge of what our species has ever done. Every astronaut who's talked about this openly says some version of the same thing. It's harder than it looks from the outside, and they'd still do it again. I think that tells you something important about who we are. We're a species that keeps choosing the hard thing over and over, generation after generation, because some part of us needs to know what's over the next hill, even when the next hill might kill us. That hasn't changed since the first humans looked at the horizon and decided to keep walking. It's just that now, the horizon is a few 100 million kilometers away, and the walking looks a little different. There's a reason space agencies spend so much time selecting the people who go. It's not just about who can pilot a spacecraft or fix a broken filter. It's about who can sit with silence, Who can handle conflict with the same three faces every single day and still choose patience? Who can watch Earth shrink down to a pale dot in a window and not lose themselves in that distance? Some of the training doesn't even happen in a simulator. It happens in isolation chambers, underwater habitats, remote stations in Antarctica, anywhere researchers can study what long stretches of confinement and separation do to the human mind before they let someone try it for real, hundreds of millions of kilometers from home. And maybe that's the quiet lesson buried inside all of this. Before we ever build a habitat on another planet, we have to understand what it takes to survive inside our own heads. Let me ask you something, and I want you to actually sit with it for a second before you keep watching. Why does any of this matter to you? Not to a scientist, not to a billionaire with a rocket company. To you, sitting here on an ordinary day, watching a video about a planet you'll probably never set foot on. I've thought about that question a lot, and I don't even think the honest answer is about Mars at all. I think it's about something much older than rockets. Every civilization that ever mattered was built by people who looked past the edge of what they knew and decided to go find out what was there. The first humans who left Africa had no idea what waited beyond the horizon. No maps, no guarantee of food or safety or survival. They went anyway. Something in us pushed them to go anyway. The people who first sailed out of sight of the land, with nothing but stars to navigate by, had no idea if the ocean ever ended. Some of them never came back. And still, others kept sailing, generation after generation, until entire continents that used to be rumors became neighborhoods. I don't think that instinct ever left us. I think it just ran out of horizon. We've mapped this entire planet now. Every mountain, every coastline, every corner of every ocean floor. There's no blank space left on the map to sail toward, except one. The one directly above your head, every single night that you probably don't look up at nearly enough. And maybe that's part of why this moment feels different from other eras of space exploration. The 60s felt like a race, a flag planted to prove a point, then largely walked away from once the point was made. This feels like something else. Slower. Less about winning, more about actually staying. There's a colder, more practical reason too, one that doesn't get talked about as often, maybe because it's uncomfortable. Every species that has ever existed on this planet, every single one has eventually gone extinct or been replaced. Most of them from causes far smaller than what could, in theory, end us. An asteroid, a supervolcano, something we haven't even thought to worry about yet. Right now, every human being, every piece of art, every book, every memory anyone has ever had exists in exactly one place. One planet. One basket carrying every egg humanity has ever laid. Becoming a species that lives on more than one world isn't about giving up on Earth. It's the opposite. It's the most serious insurance policy life has ever tried to take out on itself. But I don't think that's the real reason people cry when they watch a launch. I don't think that's why footage of a rocket landing on its own gets shared 1 million times online by people who couldn't tell you the first thing about orbital mechanics. I think it's simpler than that. I think somewhere underneath everything else we recognize ourselves in it. We see a species doing the exact same thing our ancestors did over and over for as long as there have been ancestors to do it. Looking at something impossible, refusing to accept that impossible is the final answer. Building the tools, slowly, stubbornly, sometimes at enormous cost, to go find out anyway. That's not really a story about Mars. That's a story about us. And maybe that's why it's worth paying attention to, even if you never leave this planet yourself. Even if the closest you ever get to space is a video like this one, late at night, wondering what it would feel like to look back at Earth from somewhere else entirely. Some part of you already knows the answer to that. It's the same part of you that looked up at the sky as a kid and wondered what was actually out there. Carl Sagan once described Earth as a mote of dust suspended in a sunbeam. when he looked at a photograph taken from the edge of the solar system, showing our entire planet as a single, faint point of light. He wasn't trying to make anyone feel small for the sake of it. He was trying to make a different point, that on this pale dot, everyone you've ever loved, every war, every triumph, every quiet, ordinary Tuesday happened. All of it in one place. I think part of the reason space travel pulls at something so deep in us is that it forces that same perspective. It's hard to stay angry at a stranger or obsessed with something small when you really let yourself sit with how tiny and precious this floating rock actually is. Becoming a species that reaches beyond it doesn't shrink that meaning. If anything, it multiplies it. More
If you've made it this far with me,
to continue.
I want to say something.
More sunrises
Just for a second
on more
before we
worlds
keep going.
for someone
If
to
this
watch.
is the
kind of thing you think about too. Late at night, staring up at a sky that suddenly looks a little less familiar than it did an hour ago, consider sticking around. We put out a video like this every single day, and I'd genuinely love to have you back tomorrow. And before we go any further, I want to ask you something honestly. If humanity does become a species that lives on more than one world, what do you think we carry with us? What's the one thing from here, from Earth, that you'd want to make sure survives the trip? Tell me in the comments. I read every single one. Okay, back to it. Because there's one part of this story we haven't touched yet, and it's the part that makes everything else stop feeling theoretical. Timelines. Not vague, someday, maybe in our grandchildren's lifetime timelines. Actual ones. Numbers that engineers are currently working against. Right now, this year, there's a vehicle in development, taller than a 30-story building, designed from the very beginning to be fully reusable. Not the booster only. All of it. The idea is a ship that lands, gets refueled, and flies again, the same way an airplane does instead of the same way a firework does. Test flights have already happened. Some have ended in spectacular explosions, which sounds like failure until you understand how this industry actually works. Every explosion is data. Every failure shaves months, sometimes years, off the timeline for the version that finally works. That's a strange kind of progress to watch from the outside. A rocket blowing up doesn't look like success, but ask any engineer in that control room, and they'll tell you, most of the time, they learned more from that explosion than from 10 successful flights in a row. Meanwhile, a separate program is aiming to put humans back on the moon, this time not for a few days of flag planting, but as the first real step toward a lasting presence there. Test missions around the moon without landing, then missions that do land, carrying the first woman and the first person of color to ever walk on its surface, which matters, because who gets to be part of this story has never been guaranteed. It's been fought for, every single time, by people insisting they belonged in it too. And underneath all of that, quietly, agencies and private companies are mapping exactly where that lunar ice sits, running the numbers on what a base near the South Pole would need to survive its first decade. None of this guarantees a specific date. I'm not going to stand here and promise you boots on Mars by a certain year, because space has humbled every single person who's ever made that kind of promise with total confidence. Delays happen, budgets shift. Politics interferes with plans written by people who don't answer to politics. But here's what I can tell you with real confidence. The gap between now and then has never been smaller. The hardware exists. The physics is understood. The only real questions left are about money, about will, about whether we keep choosing to fund the hard thing instead of the easy thing. And history has a pretty clear answer for what happens when a species decides something is worth the cost. We build it. Slower than we hoped, sometimes messier than we planned, but we build it. I think that's exactly where we are right now. Somewhere in the messy middle of building something extraordinary, close enough to see the shape of it, too early to call it finished. Which means you're not watching history from the outside anymore. You're watching it happen in real time, one test flight, one landing, one crater full of ice at a time. There's something else worth sitting with here too. Go outside tonight if you can, just for a minute. Look up. Somewhere up there, right now, tonight, while you're standing in your yard or on a balcony or by an open window, there are people in a station moving faster than a bullet, circling this planet every 90 minutes, watching 16 sunrises in a single day. There's a rover on Mars, alone, still sending back photographs of a world it will probably never leave. There's ice sitting in the dark, at the bottom of a crater on the moon, waiting for the first hands that will ever touch it. None of that was true 100 years ago. Most of it wasn't true 50 years ago. We started this video with a rocket the size of a skyscraper, thrown away after 11 minutes because nobody had figured out how to do it any other way yet. We end it with rockets landing themselves, over and over, engineers 3D printing shelter out of the dirt of another world, and a species quietly, stubbornly, teaching itself to survive somewhere that was never built for us. That's not a movie plot. That's Tuesday for the people working on it. I think what gets me most, thinking back over everything we've talked about, isn't the rockets or the timelines or even the ice. It's the people. The ones willing to sit inside a metal box for 7 months, homesick in a way most of us will never understand, just to find out what's on the other side. The ones spending years designing a wall made of dirt so that someone they'll probably never meet can survive a night they'll never witness. Every single one of them is doing something our ancestors have always done, looking at the edge of the map, deciding it isn't the edge, just the next place to go. Think back to the beginning of this video, to that question I asked you. What if the future of space travel isn't something your grandchildren will read about in a textbook? What if it's something you're going to watch happen? I think by now you already know my answer to that. It's happening in the test flights that end in fire and get called progress anyway. It's happening in a crater on the moon that's never seen sunlight, waiting to become someone's water supply. It's happening in a small hydroponic chamber on a space station, where a handful of chili peppers just proved that life doesn't ask permission before it adapts. None of it is loud. None of it announces itself the way the movies always promised it would. There's no single dramatic moment where someone plants a flag and the world stops to watch. It's slower than that, quieter than that. 1,000 small, stubborn decisions, made by people you'll never meet, stacking up into something that will eventually look, in hindsight, inevitable. That's how most of the biggest things in human history actually happened. Not with a bang everyone noticed at the time. With years of unnoticed work that only made sense once you could see the whole shape of it from far enough away. You don't have to become an astronaut for that to mean something to you. You just have to remember, the next time someone tells you a thing is impossible, that impossible has a pretty short shelf life around here. If this video gave you even a few minutes of that feeling, do me a favor. Share it with 5 people who'd sit with you and watch the sky the way we just did. Subscribe if you haven't, because we do this every day, and I'd love for you to be here tomorrow too. And before you go, tell me honestly, in the comments, what you actually felt watching this. Not what you think you're supposed to say, what you really felt. And tell me what you want us to talk about next, because some of the best videos on this channel started as a single comment from someone exactly like you. Somewhere out there, past everything you can see tonight, the future is already being built. We just haven't caught up to it yet.